Hey, what's going on YouTube? Welcome to the next installment in our series Building a Render Engine in C++. So last time what we covered was actually modifying the coordinate system so that instead of the triangle being rendered to a box over here, it actually renders to the whole screen with the center being at 0. So to show that in effect here, one more time, you can just see the triangle rotating as we expect. Now, one thing you'll notice is there's actually a cursor blinking down there, and I'm just going to real quickly fix that. To do that, we're just going to do curse set 0, and that will actually remove the cursor from there, and you will no longer have that annoyance. The next thing I want to do at the start of this tutorial, just for a bit of housekeeping purposes, is we can, if we go into framebuffer.cpp, we're using an offset x and offset y, and first of all, the code here is wrong. You'd need to do I is less than offset x plus that and a bunch of other changes, but I'm just going to simplify this, and we're not going to ever use the offset, so I don't feel bad about just completely getting rid of it. And then starting these at 0, so make sure I equals 0 and j equals 0 to start, and then I is less than width and j is less than height. And then in framebuffer.h, just go ahead and remove those as well. Finally go to rasterizer.h, and then remove that from there in present frame. And now if we make and run, nothing will change. But we also have in main present frame and rasterizer is taking in this x and y, so get rid of that. And now from there as well. And that will be the final change for that section. Alright, so now that that's out of the way, in this tutorial I would like to cover frame buffers and double buffering one more time. Last time we covered frame buffers, what we did is we simply set up the system so it renders to a frame buffer and then to the screen. But that's not the most efficient way we can do this. The most efficient way would be to have the frame buffer render to one while presenting the other on a different thread. So that's what we're going to implement in this tutorial. So if you imagine, let's say you have a frame buffer that you're clearing and then rasterizing onto. At the same time, immediately after doing that, you present the other frame. So the way that's going to be working is while it's presenting the frame, it's rendering the next frame as well. So to begin with this, I'm just going to keep FB here the same. So we're going to do frame buffer, buffer pointer, frame buffers, and we're going to make that size 2. And we don't need to change FB, that's completely fine as it is, but this is how it's going to be for now. And then also we're going to create another integer, current buffer, and that's going to be equal to initialized to 0. So go into this, go down to initialization list, and then set current buffer to 0. Right there. So now we actually have the frame buffer set up and the current buffer set up. So let's create an inline void swap buffers. So we'll create a swap buffers function, and then we'll do FB is equal to frame buffers sub current buffer, and then right before this we're going to do current buffer XOR equals 1. Now if you can see what's going on here, current buffer XOR equals 1 is going to, if current buffer is equal to 0, I'll just draw the truth table here. The way this works is if current buffer is equal to 1 and then you XOR it with 0, the truth table for that is, of course, as you know, XOR is one or the other but not both. But here you see 1, so then this output's 1. But let's say it's 1 already. You XOR it with 1 because that's what it's currently set to. 1 XOR 1, if it's both, it becomes 0. So you can see how when it's 1, it swaps back to 0, and when it's 0, it swaps back to 1. So that's how we're swapping the buffers here. And now what we need to do is we can go ahead and make this frame buffer pointer. We'll call this, I want to rename this to present frame, and then I want to rename this or create this one and name it render frame. So then in this, we'll have present frame is equal to that, and then render frame is equal to the opposite. So once again, the initialization list, we need to switch this to present frame null pointer, and then the other one needs to be render frame set to null pointer by default. And of course, current buffer is set to 0. Present frame, what's the issue here? Expression must be modifiable. Right. So I actually named a function present frame already. So I'm going to name this P frame, and then I'll name this R frame. So R frame and then P frame. So now in the clear frame section, this is going to be part of the render thread. So R frame dash clear, and then present frame, this is part of the present thread. So P frame dot print. So that'll present the present frame, and this will clear the current rendering frame. So now, of course, what we need to do is change this to P frame and this to R frame. And then in the initialize frame buffer is the first thing we need to change. We can call this frame buffers sub 0 is equal to that, and then frame buffers sub 1 is also equal to that. Now go into the destructor and then delete frame buffers sub 0, and then do the same thing with frame buffers sub 1. So that's going to properly delete the frame buffers. And then in rasterized triangle, the only change we need to do is frame buffer pointer FB is equal to R frame. And then that is going to correctly update it for everything there. So now that we have all that set up, if we go into main.cpp, and then if we clear the frame, present the frame, what you'll notice is if we run this, nothing's going to actually present onto the screen. Or we'll get an error, which is also acceptable. FB was not declared in the scope, and that would be because, of course, we forgot to change this to, I'll get rid of that function entirely. Well, actually, yeah, we don't need that because there are 2 active frame buffers anymore now, so we really don't need to get the current frame buffer. I kind of want that all encapsulated behind this wall. So if we make, and then what you'll see is nothing happens. Segmentation fault. That was the segmentation fault was a bit unexpected, so, oh, I know why that would have happened. It's because these things are set to null initially, and then when we create the rasterizer, it doesn't actually initialize those things, so what we can do is we can call swap buffers at first, and that way the Pth frame and R frame are properly initialized. So now we won't see anything, but we also won't have a seg fault, as you can see. Now the reason why we're not seeing anything is because imagine current frame is set to 0 right now. Well, actually we called swap buffers, so it's technically equal to 1. But when it goes to present frame, it's presenting the current buffer, which is 1, but when you call the render, it's rasterizing to the 0th buffer. Now the reason why that's going to mess things up is because you're rendering to one buffer and then presenting the other. And there's obviously nothing written in the buffer that you're presenting, but you're continuously writing to one buffer without ever switching to the other one. So the way we'll fix that is just come down here and do rasterizer.swap buffers and make run. Then now you can see the triangle prints perfectly. So it's rendering to one and then printing the other and then rendering to the one that it just printed it while presenting the one that it just rendered to. Alright, so that's the essence of double buffering. However, we're not getting any performance gains with the way it's set up right now. And that's because we're not doing anything on thread. So imagine if we were rendering to one thread while we were presenting the other frame. And that's just what we're going to do here. So what I'm going to set up here is a callback function. We'll just make it return a boolean because why not? Bool render cb, and then takes no parameters. So this will be called by the rasterizer, and then it's just going to run this function on a thread whenever it is asked to present the frame. So To set this up, I'm just going to need to do float angle equals 0 as a global. I'm going to need to do, I know this is bad practice, but for the sake of the tutorial and simplicity, I'm just going to do it this way. And I want a rasterizer pointer in this case, because if I create it as a global, at first WW and WH are not initialized, so it's going to say that it's 0 and 0, which is not what we want. So we have to initialize it after we call these functions. But if we're going to make it global, it needs to be initialized at the top. So rasterizer, we're just going to set that to null by default. And then now that we have those globals set up, we can actually come into here and then copy all the way up to line 40. And we take the angle, and then we create the vertices, and then we clear the frame, and then we rasterize the frame. Now, of course, rasterizer is now a pointer, so just come over here and make these the arrow operators to stay consistent with C++, and also so it doesn't yell at you for errors. And then what we want to do is rasterizer equals new rasterizer wwwh. Whoops, wh. And then finally at the end of nwin, delete rasterizer, just like that. Now if we run it, it's not going to present anything. And no return statement, let's just fix that real quick. And I don't know why I made it return a boolean, but that'll be fine, I'm sure. But you'll notice it doesn't print anything. But you might ask, oh, but we're presenting the frame and swapping the buffer. But the reason why we're not printing anything is because it never gets to render callback. So what we need to do is set that up in the rasterizer. So first let's add the callback function. We'll just have a bool pointer render CB. I'll just be explicit and call it render callback. And then, just like that, it has no parameters. And then in the initialization list, I'm going to initialize that to null. So now let's have an inline function here. And then we'll take it as a parameter. And then we'll just set render callback equal to render CB. And just like that, when we call the render CB function, we'll be able to set the correct callback function here. Now, we're still not actually using this callback at this point, but as you'll recall, what I wanted to do is, when we're presenting the frame, I want to, at the same time, be rendering the next frame. So the way we're going to do that is just come down here and do, well, first what we want it to do is include thread. You know what, I'm actually going to do this in the CPP file. So copy this over to here. And then make this clear frame, whoops. Make the present frame function just a definition or a declaration. And then, of course, rasterizer : present frame. And then let's put it right there. And then delete the inline. Okay, and then delete the inline from here as well. So void present frame, and then here void rasterizer present frame, and then we just call the same thing print, and everything will not work yet, as you can expect, because we haven't actually called the render function. But the first thing we need to do to make this actually work, here we need to do -lp thread. This wasn't in the make file before, but it is now, so just throw that in here. That of course assumes you're on Linux, otherwise it should automatically link. But go ahead and link the pthread library, and then include here thread as per normal. And then into present frame, we want to do std thread, and then we'll just call this render thread, and then we'll give it the pointer to the function, which takes no parameters, which is, of course, render callback. So we'll give it that, and then after we're done presenting the frame, all we need to do is do render thread, render callback, render thread.join. So therefore, whatever was not finished in the render process after the printing will be continued before the program continues, to avoid things like screen tearing and things like that. Alright, so now if I run, we have a seg fault. Let's see why that would occur. Oh, it's because we never actually set the callback. So of course what we want to do here is if render callback is not equal to null, just to be safe. If it is set to null, there's no reason to print because there's obviously nothing that was rendered. So if it's not equal to null, we'll do that so that way we can avoid the seg fault in the case of bad programming. And then all we have to do is come into main and then set that. So do rasterizer set render CB and give it render CB. Now make run, and just like that, everything is working as it was when we started the tutorial, but the difference is we're rendering at the same time as presenting. So that is double buffering for you. I hope you all enjoyed, I hope you learned something, and I'll see you all next time.